So today I'm going to introduce to you the term decimal fraction. So of all the fractions that you can think of, consider the ones whose denominator is 10 or 100 or 1,000. You get the picture, a power of 10. Those fractions, we somehow treat them a little bit more special, and we're in fact going to give them a name. So let's see what I've written here for you. Fractions whose denominators are equal to powers of 10 are called decimal fractions. So here are two examples. 17 over 10, it's a decimal fraction because its denominator is 10, which is a power of 10. 8,967 over 100 is a decimal fraction because its denominator is 100 and 100 is a power of 10. So for these fractions, today I'm going to show you how we can rewrite them, abbreviate them if you like, into a nice shorter form. And this notation I'm about to give you is due to a German Jesuit mathematician and astronomer by the name of Christopher Clavius, and this notation is from has existed since 1593. And so here's how the notation goes. And this is the abbreviation that Clavius introduced. He said that we know the denominator is always going to be a power of 10. That means it's always 1 followed by a certain number of zeros. So how do we keep track of those zeros? So here's a method he devised. He said, well, simply rewrite whatever number you have in the numerator, rewrite the whole number, and to say that the denominator was really 10, or there was a 1 0, we need to keep track of the 0. He said, put a dot in such a way that the number of digits to the right really keeps track of the number of zeros in the denominator. This point is called the decimal point. Oops. The digits to the right of the decimal are called the decimal digits. So the number of decimal digits match up with the number of zeros in the power of 10. So let's see what we can do out here. We rewrite the whole number, and now we need to place the decimal point in such a way that if you count the digits to the right, the decimal digits to the right, they match up with the number of zeros here. So we have 2 zeros here. And so if we were to put the decimal point right here, that's perfect. 2 decimal digits matches with 2 zeros in the denominator. So this is the short form condensed notation that Clavius introduced. And we will see as in other videos that this notation makes it very easy for us to deal with decimal fractions. We don't need to write this over whatever 10, 100 and so on. And this decimal, somehow this abbreviation notation, this abbreviated notation makes our work much easier. It makes it look like we're just working with, in fact, whole numbers. It's not like as though we're working with fractions. And we'll see that in other videos. Let's quickly review some of the new terminology. The number you see here, we see that there are digits, and then suddenly we see a point here, and that indicates to us that this number is what we call a finite or a terminating decimal, sometimes just decimal. So this number that you see here is what we call a decimal number. This point that you see here is called a decimal point. Each digit to the right of the decimal is called a decimal digit. And then in the other videos, we'll see how to rewrite a decimal fraction as a finite decimal. And we'll also, in another video, we'll see how to write finite decimals such as this, how to convert it back into a decimal fraction.